right? We find out up to these points for the first octant, and we have not plotted that on the graph, and also need to find out all other octants, right? That is the situation that we have.
Yes, sir.
Okay, and for the first octant, if we go for actually find out all the points, say like the points should be for the first quadrant. So we are writing like first quad, where actually the coordinate value is actually x and y, right? Uh, and then for the second quadrant, say like this one, that if we consider that second quadrant is this one, okay, is minus x and y. Third quadrant is this one, which is minus x and minus y. And the fourth quadrant is this one, which is actually x minus y. That is x and minus y. Okay, so these are maybe actually the all four quadrants that we have got. Now, if we consider for the first octant that we have actually got the points, they are the first point you need to include with that 0r that we have taken, the first point, which was 0 and 10, right? Then we get the second point is 110, 210, 310, 410, like this way. So the second point is 110, 210, 310. Then we have 4959. Okay. Then we have 4959. Then we have 68, 68, and then 77. And we stop the algorithm on that point because actually we have found like where the x and y equal there actually, and we have the condition that x is greater than or equal to y, then we have to stop. So these are the actually point in here that we have got for this 1 2 3 4 5 6 7, this 7 points actually we have. 7 is a point which is actually exactly that point we have got in between these two octants. So 7 point we have, so other 7, that the point for the second octant that we can actually find out as we can reverse those point x and y coordinate. So as you can understand why it is actually exactly in the middle point, because 7 x and y, if you reverse it becomes same. So it is actually the only point that we have. Now 6 8 will be 8 6 now, when that x is actually becoming y and y is becoming x. Then 5 9 will be 9 5. Then 4 9 will be 9 4. Then 310 will be 10 3. 210 will be 10 2. Then 110 will be 10 1. And 0 10 will be 10 0. Okay, 10 0. So these are actually the all the points of the first quadrant. As you can see that this is actually we have got from that 90 degree to 0 degree, that first quadrant, all the points are in here now. Now, the easy way, if we just change the sign of those all these coordinate values for the x and y, then actually we'll get actually the second quadrant points. So that we will find here 0, that is minus x and y for the second quadrant. So now 0 and minus x and y is actually 0, does not make any change. So 0, 10, then minus 1, 10, minus 2, 10, minus 3, 10, minus 4, 9, minus 5, 9, minus 6, 8, minus 7 and 7, minus 8, 6, minus 9, 5, minus 9, 4, minus 10, 3, minus 10, 2, minus 10, 1, and minus 10, 0. So this is actually the point we have got for the second quadrant, as you can see. And the same way that if we go for find out that third quadrant value, that is actually 0, minus 10, minus 1, minus 10, minus 2, minus 10, minus 3, minus 10, minus 4, minus 9, minus 5, minus 9, minus 6, minus 8, minus 7, minus 7, minus 8, minus 6, minus 9, minus 5, minus 9, minus 4, minus 10, minus 3, minus 10, minus 2, minus 1, minus 10, minus 1, minus 10, and 0. Okay, that is for the third quadrant. And the same way that we will go to get 0, minus 10, 1, minus 10, 2, minus 10, 3, minus 10, 4, minus 9, 5, minus 9, 6, minus 8, 7, minus 7, 8, minus 6, 9, minus 5, 9, minus 4, 10, minus 3, 10, minus 2, 10, minus 1, and 10, 0. Okay, so these are actually all how many points, like 3, 4, 5, 6, 7, 8, 9, 10. So 7, 7, 14, 15. So 15 into 4, so 60 points, 60 pixel that actually we have got, so that we can actually generate the actually circle now. You can see here that it's actually some kind of a speciality that you can get. Usually this 4 of that quadrant, if you just check in the circle here, for any circle, you see the 4 quadrant, all the points should be unique, right? Have you seen that? Is there any chance of those points should be, or pixels should be actually common? Usually it should not be, because they are actually pixel, but somehow the coordinate 0, 10, 0, 10. So first and second quadrant, there is actually point for common, which is saying 0, 10, 0, 10. Now the pixel would be different. That is actually the case. Like 0, minus 10, 0, minus 10, third and fourth quadrant, that they have also some kind of common. You can also see at the end as well that first quadrant has 10, 0, and fourth quadrant has actually 10 0, while the second and third quadrant has actually minus 10 and 0. Okay, so there are actually you can see the points, they have something common. Okay, and that common thing maybe we can go for to plot. uh, Even that graph plotting also I found like a student made mistake with your Bressenham actually, or even on that point as well for DT algorithm. That is also actually few students made mistake that whenever they are going to plot, they actually try to do something what they thought like this is my graph. Many students did not even define that the values they did not put, like if this is my origin 0 and 0, eventually we take this is 1, this is 2, this is 3, this is 4. This is the way you need to write down. You left it for your teacher to count. Now the problem happen, some student define this is 1, this is 2, this is 3, this is 4. You may count those as a pixel actually number but not the coordinate. Whenever we have 1 1, okay, say like we have a coordinate value 1 and 1. Now that 1 1 is a coordinate point, x and y in a reflect actually it's going to have a pixel. Now what you have done when you define like this 1 2 3 like this way in between of the pixel, then what happened 1 1 you said maybe this is my pixel, but this is wrong. This pixel as a address is actually belongs to 0 0, because the origin is actually moving away this like this way, and for this case this pixel belong for this actually coordinate point. So 1 1 should be 1 and this 1, this is actually the point. Some of you also did not actually identify the pixel, only the point, and then you just left it. For that actually this is actually the pixel. Okay, and that will be actually selected. So many students made mistake in that. With the same way, with for this many number of 60 number of this pixel for the graph, if we go for actually plotting for that, you can see here that the graph that we have mentioned for 0 10 1 0. Now think about the first quadrant, that which is actually 0 10. So the first quadrant is this side. So 0 10 it is indicating this way. So the pixel you are going to count actually from this way. When it is for second quadrant, then your direction is change. It will be in this way. Okay. When it is actually going to be the third one, then it is going to be this way, and fourth one is this way. Okay, so whatever the coordinate value you got, on the basis of that you are going to take actually that pixel. So like if it is 0 10 1 10, so what should be 0 10? So 0 and the y coordinate is actually 10, so this is actually the point. Okay, for that point what should be actually the pixel? The pixel should be this one. Okay, for this quadrant the pixel should be this one. Now 110, so that 1 and 10, so this point, so the pixel should be this one. 210, so point is this one, so the pixel should be this one. 310 is this one is 3 and the 10 is this one, so 310 is actually this one. Okay, then the 4 9 we have actually after 310 is 4 9 and 5 9, so the 4 is here and 9 is actually this one, so the pixel should be this one. and 59 point this one, and the pixel should be this one. Okay, so 4959, the 68, so 6, and this is actually the 8. So for this point, the pixel should be this one. Okay, then 68 after that 77, so the 7 in here, and 77 is this one, so the pixel should be in here. Now you see that our first octane part is done, because that is actually the major point that we are actually already got, 77. Now that is followed with the reverse of this point. So we have got in the reverse is 8 6, so this is 8, and then the 6 is this one, so this point, so that this is actually a pixel. Then 6 8 after 8 6, after that 9 5, then we have actually 9 5 and 9 4, two of them for the 9. So this is 9 and this is 5, so 9 5 and 9 4, 9 4. Okay, so 9 5 9 4. Then we go for the 10 3. There is now all the 10, 10 3, 10 2, 10 1, and 10 0. So that we got now 10, and then 1 2 3, so this point, so 10 3, 10 2, 10 1, and you see 10 0. Okay, so this is the point. So for that actually the pixel is this one. So do you see that this is actually my circle, that coordinates for the first quadrant in between with this first octane and second octane that actually we have got. Do you get it?
Yes, sir.
Now for the second quadrant, the same point, 0 10. Now this is interesting. Now you need to understand, for first quadrant we move actually this way from the origin, second quadrant that we will move this way. Okay, so that whatever that 0 10 we had in first quadrant and second quadrant, the pixels are different, even the coordinate is same. So this is actually 0 10, this point. So for first quadrant, the pixel was this one. The second quadrant, the pixel will be this one, right? For having the same or common quadrant coordinate value. So that's why every of those two quadrant common that coordinate value, you are going to have in the both side two different pixel for the different quadrant. So as it is, this is actually 0 10. Then we got actually minus 110, minus 210, minus 310. Now how it can be? Minus 1 is actually, this is 0, so that minus 1 is this one. Okay, so minus 110, that means this point, that means this pixel. Minus 210, that means this point, that means this pixel. Minus 310, that means this one, that means this pixel. Okay, so 0 10, 110, minus 110, minus 210, minus 310 that we have got. Then we got minus 49, minus 59. Okay, minus 49, so that this is actually minus 4, and this is actually 9, so that this is that pixel. Okay, minus 49. Then we go for minus 59, that means this pixel. Okay, then minus 6 8, so minus 6 and 8, that means this pixel. Okay, then minus 7 7, minus 7 and 7, minus 8 6, minus 8 and 6, that means this one. So this is 6. Then minus 9 5 minus 9 4. So minus 9, and this is actually the 5 9 5 and minus 9 4. That means actually this one. Okay, and minus 10 3 minus 10 and then 3 is this one. Okay, and minus 10 2. So minus 10 2 minus 10 1 minus 10 1 and minus 10 0. That means this one, right? So that this is we got for the second quadrant coordinate values, and you see that getting a shape now for that half of the circle. Now that actually we have got a shape for the same way that if we can actually draw for the other two quadrant, which is 0 minus 10, as you can see, and 0 minus 10, both of the cases. So for the y coordinate, 0 minus 10 is actually what, this one, isn't it? 0 and minus 10. So that this point is also give you in the both side, as you can see here, that in the both side for fourth quadrant and third quadrant, like this one as well. This is actually that minus 10 0 that you will get for minus 10 0 for second quadrant. The third quadrant you will get, that is actually for this pixel you are going to get. The same way for the fourth quadrant you will get that 10 0, only 10 0 that we have, as you can see, that only 10 0 as like first quadrant, that is actually going to give you this pixel. Okay, so I hope that you can plot those other two quadrants actually points, and actually you can get it right.
Yes, sir.
Is it fine?
Yes, sir.
Okay, that is okay. So any question about this algorithm and this plotting the graph? Do you have any question or anything?
No, sir.
Anyone have any concern? So you have in your final exam one of the question from this one. You can do it, right? All of you?
Yes, sir.
But sir, it will take more time.
Yes,
It
sir.
will take more time. Yes, this is little bit time consuming for plotting that one. So you may have actually less number of points maybe in your exam, but you have to, if you can do it, it will not take that much time. You need more time when actually you do a struggle, right? Otherwise it should not be. As you can see that plotting the graph does not take that much time actually, if you you know that where actually you are going to plot. I hope, is there anyone here that you can remember that you made a mistake on the graph in the midterm? Is anyone, can you identify that you made a mistake maybe?
So yes, sir.
That plotting the graph maybe, and this is actually, I told you that yesterday as well, that I really feel bad. Even a student plotting the graph, they have actually just copied, not even one counted by themselves that okay, let's see that where actually it can be put. But you have actually done some kind of copy that that is actually very unfortunate. And the mistake who has actually done for the first time, the mistake they have done, and you also actually done the mistake as according to them. So now this is the plotting. I think you understood about the pixel. This is do not mix up with the pixel and the coordinate. The coordinate is actually their intersecting point. The pixel is actually the box. So that we need to actually look at carefully about the box that actually we are going to identify. End of the day, all the drawing that we have done in this chapter, these three algorithms, that whenever you go for plotting in the graph, you should consider actually the pixel, not the other thing. All right, that's fine. Then let's move on. I think this is we have done the assessment for that Bressenham already for DDA. We may have due with actually this algorithm with the midpoint circle drawing. I hope that this is definitely one question you will have in your final exam. Okay. Let's move on to actually the different topic as we will go through now, maybe a little bit quick. And this is actually called the color models. Okay. As you know that in color models that there are actually there are actually two different models that we are going to discuss. You already started to use the colors maybe for your assignment as well, as you know that the colors that has a very interesting part in two ways that can be defined in our daily practice as well, as you know in the digital screen that we can see, and in real life that actually we are using the color. And the color, you know that with the electromagnetic that radiation that we have, the light that light is actually consist of many number of color actually intertwisted, right? They are actually twisted in the different wavelength. As you have a different wavelength, the range of the wavelength, most of you have memorized that one, so that during the viva, whenever I have asked you, say it actually about the wavelength, that 350 to 780, right? That nanometer of the wavelength. Now, this different wavelength actually give us actually the different color that it has. So that there can have actually many combination. Now, in the color display, whenever we have discussed that the very common to approach for the CRT based display, that whenever we have discussed that beam penetration method and shadow mask method. Can you tell me which one is for which type of graphics? Can anyone remember? Anyone can remember?
Shadow mask.
That
Sir, beam penetration for raster graphics?
and shadow mask is for vector graphics.
Yes, sir.
Okay, that is exactly opposite. Okay, beam penetration, you can remember, it is indicating the beam, the light beam, right? Or the beam of the electron is strongly try to put on the actually screen, and it try to penetrate, enter, it try to enter actually. And the coating of the screen that we have, that green and red, so that actually try to illuminate that portion, and it creates some colorful light. Now it has a limitation that only that four combination of the color it can possible to do for the vector graphics. So it is not good for actually the real life images. But the shadow mask is actually that metal disc that we have, which actually falling on the specific pixels with a combination of red, green, and blue. The delta shadow mask, if you can remember, are actually used for the raster graphics. Now, in the beam penetration method, this is just a quick recap that actually we are doing here. It is actually for displaying the color picture. It has been used with random scan monitors, as you can see, the vector scan monitors. Okay, and two layers of phosphor you have, that red and green, and which are coated onto the inside of the CRT screen. So you can remember that red and green in the CRT screen inside that it has, and they have actually that color you may generate depends on how strongly you can throw that beam on that electron beam on that is actually screen, and on the base of that intensity of that beam, that you can actually have different color. So very first actually the electron go through the red layer, and the inner layer is actually green layer. On the top there is actually red color there. So that first electron touch the red layer, and then try to glow the internal that green layer. And the speed of the electron, that is actually the screen color at any point, is controlled by the beam acceleration voltage. So it's a actually voltage generator which actually try to throw the beam, and actually it try to generate the light. And it is actually very inexpensive way to produce the color in vector graphics that monitors, but only 4 colors are possible. Okay, so picture there's quality you cannot expect, especially it is for drawing the line we have seen for the color display as well. For designing for the image is actually okay, but real life image is not possible. So this is the beam penetration method. If we go for shadow mask method, as you can remember, that 3 gun that we have and a metal disc that we have, actually that's why it's called the shadow mask. It works like a mask, and those dots, small holes in that metal disc, that actually can help to fall the electron beam exactly on the precise places on the those pixel that actually you can have. You can see here that these are actually sub-pixel level on that red, green, and blue combined in a delta shape and create actually a pixel there. Okay, now the three gun for 3 different colors, primary colors, they actually, according to their intensity, they actually goes through that, and metal mask can actually can illuminate those pixel. And a phosphor pattern of striped picture tube, that is actually, you can see here that slotted shadow mask. Okay, that shadow mask is actually have rectangle shape, where also like pixel that actually also kind of a round hole. It also can have actually that rectangle shape, where the light is actually goes through and fall on that red, green, and blue, as you can see that this sub-pixel level. And that is also actually available. We have seen in the one of the CRT maybe during one of the video that they were having that those rectangular shape of sub-pixel level. Even in the OLED television, that the pixels in the sub-pixel level are actually kind of a rectangular shape created with 3 of them. And the working process of the shadow mask already we have said. And CRT has 3 phosphor color dots at each pixel position, and one phosphor dot emits a red light, another emits green light, other third is emits blue light. We know it, and it's also called the delta shadow mask, because these 3 beams pass through a hole in the shadow mask and activate a dot triangle. It can create a dot triangle, and which is actually appears a small color spot on the screen that we know. So that's actually our 2 technique can be applied for color display. Okay, that we actually done as we are discussing about color in this chapter. So we just quick recap that we have done. We know that this is actually indicating for vector graphics color display. This is actually indicating the raster graphics color display for it. Now, for color, we have a very strong relationship with the memory. Okay, as it is recalling the frame buffer, as you can remember. So frame buffer is actually special part of the memory, thought as a computer memory, organized as a 2-dimensional array with each of x and y addressable location corresponding to 1 pixel. So for 1 pixel, it has a relationship. You can remember the color depth, right? One of the property we have discussed, color depth, color value. Can anyone remember? Yes.
So, color value is RGB, and the depth.
Color values RGB. Okay, and depth.
How was
Yes, Antar. You are muted. I think you are talking.
Okay. Huh? No,
So that color value is actually RGB Ashik said. This is actually a value which is having red, green, and blue. That the intensity, according to the intensity, actually you have some proportion of the value that you have. Now, the color depth is actually in each subpixel level, even that with that red or for green or for blue, that how many combination of the value that you can take, that has been defined. Okay, so that's we can actually also say it for a 1 pixel, that can be 2 to the power n number, that color depth. So if I can say like depth is actually 8, then 2 to the power 8, so 64 possible different colors can be generated. Okay, that is actually the depth of the color. Now this is when we say 8-bit depth, you see that already it comes that 8-bit. So this laptop you can see here, it's in color depth is actually 32-bit. Commonly you will find like this is maybe the highest. So 2 to the power 32 combination of the color. So 32-bit for each pixel has been assigned 32-bit memory for actually generating the color, the option for the color it can generate. So every cases, every time the color has been defined, it has a relationship with the memory, as you can see here, that has been defined. So bit plane or bit depth is a number of bits corresponding to each pixel. That this is just for actually visual representation, that the bit are maybe the two-dimensional array, that one to like a small plane. Okay, that can be actually assigned maybe for number of bits. If I say like, okay, for this pixel the bit depth is 8, that means 8 of that array of bit planes are actually assigned for one of the pixel. Okay, like this way it has been defined. A typical frame buffer resolution might be like 640 into 480 into 8. So it is indicating that 1280 into 1024 into 8, indicating that 8-bit depth color buffer that you have for that resolution for 640 to 480. So indicating 640 is actually what?
Columns and row.
640 is column or row?
It's
Sir,
column.
column.
Sir.
640 is column and 480 is row. Yes, as it is x coordinate value, this is actually y coordinate. This is also I found like some is very few students made mistake with that. You can remember we had the second question maybe for pixel identification. So the VGA definition also they have made a mistake. Okay, and 8 is indicating the 8-bit, like 24-bit depth. This is actually the true color. Already we actually studied over earlier, because 2 to the power 24 combination, that means that many color are actually possible. A human eye can find out the difference of the colors. Otherwise, the next actually it goes, they cannot actually find out the problem, find out the difference. Now, monochrome display, that means 1 bit maybe that has been defined, as it may look like that. So your gun is actually defined with 1 bit. 3-bit color, whenever we have, say like in red, green, and blue are actually defined with 111-bit plane. And 3-bit, as you can see, 2 to the power 3, that means what are the possible color? We can have 8 combination, right? So you can find like that 000 100 like twice combination 110011 and 111. You see, these are all actually 8 possible color can create, and these 8 possible colors are actually defined with that. The alignment is not right here, but 000 means actually the black, that means no intensity value for it, and 111 is actually white. In between, the primary color we have for red, then the green, then the blue, and then those are actually the combination color with this secondary color, like yellow or red and green, then green and blue is cyan, and magenta is actually that red and green it can have. So these are the way of combination. We have a different colors there. Now the highest is 8 this possible color it can create, because you can see here, if we go for that binary combination, that you cannot go for further more, you need maybe another bit for it. Okay, say like red is actually having 2 bit, then maybe you can have a combination of 2 bit 0 1 1 0. So 0 0 0 40 or 0 1 0 0 or 1 0 0. So there are options are actually increasing now of that 2 to the power 4. Then that means maybe 16 combination of different color is possible. Okay, so this is the way actually the relationship with the memory and the color. So true bit color display, when we say the 24 bit is actually true bit, the highest possible actually the bit that we can actually find out, where you can see that the color gun can have actually 2 to the power 24. So these are the color, maybe we can identify the different colors. So you can see that it's a huge number. I think maybe 1 crore 67 lakh, and then 77,216 different color. Maybe our brain can actually identify the difference, and that is actually possible with when you have 24 bit defined for your one of the pixel. So red, green and blue, they are mutually distribute that bit. So maybe 888 3 into 8, so that one of the position for the color that we can identify that 8 combination of that point for, as if you consider this one, so that one of the position for red is actually having that 8 number of bit, so that 8 combination of that 0 and 1. So it can be green also can be like that, and blue also can have back. So that one color for this true color display can have actually 24 bit combination. So 0 1 combination of 24 bit can define one of the color, right? So can anyone tell what should be the white color in this?
All on.
All 24 1, right?
Yes, sir.
So the black color would be all 24 is actually
Zeros.
0,
Yes, sir.
right?
Yes, sir.
Like this way actually you can make a combination. And what should be actually the blue color? So first 16 will be 0, then maybe last 8 will be 1, right? So like this way actually you can define the color. Now this is important, color map lookup table. So it's actually a visual representation, or in a representation that actually we can try to identify how it is actually defined in the memory for any pixel, that what it should be actually shown in here. And that actually in the table, there is actually in the table how actually that can be defined. And end of the day, the intensity value for the red, green and blue, what actually the intensity they are going to get, okay, that can be shown in the display here. So this is called actually the video lookup table organization, and each table entry is actually 12 bit per entry. 12 bit it is saying, so that the color depth we can understand is actually 12 bit for every pixel, that in 12 bit of the color has been defined. So say like any pixel value is 67, that means actually the address of it. How we can get that address? Maybe that is getting from actually that the resolution they have, and from there that 67 number of the pixel that has actually the red electron gun is 9 by 15. As you can see that it is actually having 9 by 15, or maximum. Green is actually having 10 by 15, and blue is actually having 1 by 15. So that is actually the number that actually we can get. So that pixel is actually having a value, that is we must actually define a value, then we can actually do for it, like a number can be given, that what should be that number. That number would be actually, you need to actually convert that into the binary form, and that in the binary form actually you can go for that distribute of that according to that pixel that has been given. So maybe you would be given a pixel address, okay, and that is maybe the value for the pixels, so like 60, 80, 67 it has been given. So we can understand that 67 is actually the pixel address that it goes for the actually frame buffer to find out that 67 pixel what actually the value it has. The value has been given, say like that value is actually some value. It is something like say 2055 is actually value, or 2079 say like a value. Now that number 2079 or 2055, that number is actually distributed in a binary format, so that first four of them, whenever it is actually 12 bits, so you need to know that how it has been organized. Like whenever have 12 bit, we can assume that they are mutually, that red, green and blue has been taken 333 bit. If it is say 24 bit, then it is also actually considered for maybe 888 bit. Now whenever it is actually that bit number has been defined, so that we can actually take and divide that actually that number for the binary number. First four we will take for red, as you can see 1001 has been taken for red. Then second four, that after that 1010 will be taken for green, and the last four, that 0001 has been taken for blue. Now from that actually 4 that binary bit that actually you have got. Now for red, what is the highest combination it can have? If you think about the combination or the value for that rate, what is actually highest we can have? 0 to 15, isn't it? That means 16 combination value, that means 2 to the power 4, right? The same way for the green as well, that is 0 to 15, 2 to the power 4, and blue is also actually 2 to the power 4. Now for this pixel, what is the intensity we are actually getting? You are getting 1001 is actually what for the binary? If we go for binary coded decimal, that BCD, that so 1248, right, according to the position, so 1 and 8, so that means actually 9. 1001 is actually
9.
9, right? So 9 intensity, that means actually you can understand now the intensity should be 9 out of 15. 15 is highest, so 9 is actually what, maybe 60% intensity, right, or 70% intensity that you can get. That for the rate, the green will be now 1010, so 1248, that means 8 plus 2 is 10. So 10 out of 15, maybe 70% there, the intensity. And blue is actually 001, that is actually the 1 out of 15, that is actually only maybe 6-7% of the intensity that the electron gun it can have for RGB, and they can actually focus on that intensity on the pixel, and the pixel will generate a combination of the light. Do you understand the structure of it?
Yes, sir. Sir, when we use the color code for graphics designing, so how does those work? Are those on in hexadecimal?
That is actually the value you use, right?
Yes, sir.
A coded value. It is actually internal structure of getting that your defined color, that what it should be, can be generated. Now this is in this part we have actually the video controller. Okay, that video controller, that accelerator, that voltage accelerator actually get the signal according to that. Okay, whenever you get that one, that is actually do. Now color code, whatever you give, that is actually giving in a software, right? And that software actually what the color graphics card actually interpret that one and give it to that actually to the processor, and that processor actually then actually identify that what should be the color. Now this is actually the possibility of the color it can generate, because the depth and color value are different. Okay, they are not same. The depth of the color that can define a different color value. Okay, but they are interrelated. Yeah, so the color depth is actually true for all the cases. Like it is saying about the range that many of that combination. Now, when you have actually a 8-bit depth or a 12-bit depth color actually that you have now, both of the cases you can generate actually black color, white color, right? Now their construction of the intensity of the color gun will be different according to that.
Sir.
Okay,
I have another class at
Sir.
9:35.
I also have a class in 9:35. Is it 9:35 already?
Yes, sir.
Already
It's a
Okay,
And we have
9:36.
all also have attendance.
yes, we will go for the attendance now. And I could not see the any watch here. That's why